Alright, Rory here with the FarmBot project. A little update regarding the universal tool mounting system. So this was version 4, universal tool mount. So over here we had the tool mount itself, which mounted with these two holes here onto the Z-axis aluminum extrusion. And then what we had was these 4 screws, or 4 holes that would have screws in them to pass electrical power and data through from the tool mount to the tool. And so you can see that those are aligned, the different formations. Now what was interesting about this design was we had down here a neodymium magnet held in. And then these screws around the perimeter were going to have springs, so that they'd be spring loaded and would depress when the tool went into the mount. And on the receiving end, on the tool, there was also a magnet, and then the 4 screws, which would just pass power or data to whatever electronics were down below. So the way this worked, it worked pretty well. Essentially, the Z-axis would come down and suction up or magnetically attract the tool into place, and then the screws themselves would act as the keyway to prevent rotation to some extent. So it worked pretty well. Super easy to attract on and off the tools, just like that. Pretty easy to remove the tool using a little bracket that would go into the groove right here and hold the tool in place while the Z-axis lifted up. So pretty neat design. What it was lacking was the ability to pass power, or sorry, not power, water or air. You know, we were passing electrical power and data, but there was no way to pass power or water or air. So that was something that we wanted in order to make the universal tool mount more universal, essentially being able to accept more tools, a greater variety of tools. So here's version 5 of the universal tool mount. So this is still a 3D printed part. It was produced with the same machine as version 4 parts, a fused deposition modeling 3D printer, RepRap. So this was all 3D printed, it's one piece, and you can see we have changed the orientation around a bit. So instead of having a single centralized magnet, as with over here, and then screws around the perimeter, we have 3 magnets around the perimeter. So that does a couple of things. First, that allows us to have more torque resistance. So a problem with this one was that it goes in there fine, but it was pretty easy for the tool to get torqued out like that. It really only had axial pull force. In this design, and here's a tool with some magnets. Some of them are taped up right now. Because there's 3 contact points of the magnets, it's much more resistant to being torqued out. So that's a better design in that regard. The second reason why we did that is these magnets are actually glued in, and you can see in the top right one, you can see all the way through right here. And so that's because these magnets are the portals to pass the power, or sorry, not the power, the water and the compressed air and also liquid amendments through from the tool mount into the tool, if the tool requires it. So for instance, this is the seed injector, so it has a small tip over here that would presumably suck up a single seed and then go over to the right spot and deposit it in the ground, cut the vacuum, and then move on. And the way this works, and the reason why these are taped up right now, is that the vacuum pump is not located in this tool. The vacuum pump is actually going to be on either the Z-axis or the gantry somewhere on the FarmBot, and then we simply just suck the air through here, which come through, in this case, let's get this on here, woo, through the other side to this barb. And that barb, let's see, can we focus this? No, it can't. That's all right. This barb, then we can put a flexible tubing on, which could then go to something like this vacuum pump right here. So this is a cheap or inexpensive vacuum pump from, I believe, SparkFun. So a little 12-volt vacuum pump that we could have somewhere on the gantry, and we could essentially power any sort of tool that requires vacuuming force. So that's really neat in the way that that works. Get this off of here, so you can see that the 3 magnets go on there quite nicely, hold the tool on very well. In fact, it might be too much, so there might be too much force holding it on. You can see that it has quite the tendency to sort of latch on really hard, and it's actually, you almost have to torque it off. There's really no way to get it off otherwise, and so that might be a problem. The Z-axis might not be able to pull with that much force. So I think what we're going to do in the next iteration is have the 3 magnets here and then just washers on the tool. So the washers will still be magnetically attracted, but they won't have their own magnetic force. So it'll be much easier to pull the tool off. So then you can see we still have the 4 screws. These screws are actually a little bit too small right now. The diameter is supposed to be an M5. These are M3. But you can see that they are on springs, so that when the tool would come onto the mate with the tool mount, it would depress these and make that nice electrical connection. So we'd have ground in the center, one of these for 5-volt power from the Arduino, and then 2 of them for data, either sending a signal or receiving one. And then on the other side, it'd just be little crimps to attach the wires to. So this is really neat. The new universal tool mount essentially can do a lot of different things. It can pass power and data through, and also water, air, and liquid amendments of some sort. So we're really excited about this one, and we'll send out an update pretty soon of this in action on the bot itself. Yeah, there we go. Some more parts over there. Pretty exciting.